Hello everyone, welcome back. So today what we'll be trying to do is something in the looks like what we're seeing right now on the screen. This is not an idea from me. Um, this comes from the r/generative on Reddit from Vector. Hopefully you go check him out. He has a website as well, which I've opened up and tried out. It is pretty cool, I think, what he's done. So basically, from what I'm seeing and understanding what I want to understand, pretty much, is that it's basically a grid of hexagons. Each hexagons is a little bit smaller than the actual size it could take. And I believe this is to give the effect that we're seeing over here. For example, over here, where you can see the background of the print, basically, and then the hexagon on top. If the hexagon were full size, then there would be no gap, basically. And then he applies some colors, maybe using, I'm not sure, maybe he used some Berlin noise for the colors. Who knows? We'll be trying out something, possibly a lot less cool than this. So props to Funky Vector again for creating these. So I'll be trying to reproduce something in the genre that this is. Great. So let me go on the whiteboard and explain what I'm thinking in my head right now for this sketch. So let me take a pen. Okay, great. So basically, we have the canvas here, right? And instead of making like a grid of squares like this, it'll be a grid of hexagons. But we'll keep the principle of like a 2D grid, right? 2D grid, right? Because it's still going a 2D grid. The only difference basically is that there is going to be an offset, basically one offset values between the, let's say, the odd rows and the even rows, right? So that's basically going to be it. So first thing first, I want to do is some rectangles, just basic rectangles or squares, whatever you want to call them. I mean, squares are a rectangle actually, so sure, we'll use rectangles. So just a 2D grid of rectangles, and every odd one, let's say, well, this would be a pair. Yeah, this would be even, but let's say every odd one is shifted a little, half the size of one rectangle to the right. And the row should start one less as well. So we might want to add like an invisible row over here, right? That would contain these, right? Basically. So that's the goal for the grid at least, right? So -1, well, +1 on the amount of columns, and we move them, let's say, back half a rectangle for the well, in this case, the even ones, right? So, any case, so that's the principle for the grid itself, and then we'll apply a background color, some type of background color, and then we'll have, let's say, we'll get a color palette of whatever. It doesn't matter. We'll get a color palette, and we'll try to randomly assign the values of the hexagons to a random value of in the color palette, and set the background to one random value as well of the color palette. So to draw the actual hexagons, I was thinking a function like hexagon here, which would receive x, y for its, let's say, its row, column, or column, row, whatever you want. Yeah, in this case, it would be column, row, and then possibly the scale. And we could pass offset, right? Oh, God. Give me a second. There we go. Let me take this. Yeah, I really need to wash this. The scale for the hexagon, and then as well as an offset, which half of the time will be 0, basically. And the other half, it will be the scale divided by 2, right? Hopefully you can see this. It's a bit on the edge, but it doesn't matter. So I'm thinking this. We could omit the offset technically and just check if the y is even or odd, basically depending on which one we choose to be offsetted. But it doesn't matter in the end. So this function is going to first do a begin shape, and then we will do a for loop. And since an hexagon, I believe it's hexagon, is it? No, pentagon is 5, hexagon is 6. I'm pretty sure. I mean, I might be wrong. Hopefully I'm not. Anyway, we need an hexagon, pretty sure, but something with 6 sides, right? So what we can do is just do a circle, but with less vertices, so 6 vertices instead of how many ever we want for a circle to look like a circle. So we'll do like a for loop for I equals 0, I is less than 6 in this case, I plus plus, and then we will get the angle, which will equal to, I don't know, the mapping of I, which goes between 0 and 6 to, or we could simply not use a map and just do the map ourselves. It shouldn't be really complicated. So we should have somewhere in here just like a variable, some variable, I'll call it 1 in here. 1 equals to 2 pi, it's going to be cramp, 2 pi divided by 6, right? And then what we can do is I times 1, right? Okay, so we've got the angle. Now we need the x, and the y should be equal to the cos, and this we'll need the scale divided by 2. So the cos of the angle times the scale divided by 2. Let me make sure you can still see. Yeah, I think you can. And y is going to be pretty much the same, but it's going to be the sin of the angle. And these are radiant angles. Otherwise, we would get 1 by dividing not 2 pi by 6, but 360 by 6, right? But in this case, we're using radiant, and we need 2 pi, which would be a full circle in radian. As the angle, right? The maximum angle of the circle should be 2 pi. So in here, scale divided by 2 as well. Great, because we need the radius of the circle, which in our case will be in an hexagon shape, and not the diameter. And the scale should be from top to bottom of the hexagon, which is the diameter. And we want the radius, so we need to divide by 2. And then we'll place a vertex at x comma y, and then we'll just end the loop. So this is ended, and then we'll call end shape. There you go. Great. So that's pretty much, and we'll pass as well like fill color or something like that for the variable. And we might want to remove, let's say, maybe do, when we're passing scale, we might want to do scale minus, let's say, 5, for example, to leave some spaces around the edges. So that's pretty much it. Let's try coding it now. There you go. Okay, great. So let's start with this. So I have a blank canvas. Let me make sure that the background for the moment is white, just because right now the background is just transparent. So wouldn't be so great whenever we do a print of these. Okay, so let's first start with the scale, right? So const, or just I have a config variable here. You can just put scale as a constant somewhere. It'll be a global value anyway. So yeah, the scale, let's say for right now, let's say 35 or something like that. Just a big one, maybe even 50 for the moment. I don't really care. Just need something big to first see if it's working properly, and then we can make it smaller. So we'll let columns and rows, just because we need the count of those. We could technically initialize them in here since we're not going to use the draw function. Well, I'm not going to be using it, but hopefully you can animate this, make it look great, or like the animation, make it look like maybe you could animate as a wave, right? I don't know. You think about it. So const columns equal the width divided by the scale. And const rows is going to be equal to the height divided by the scale. And what I want to do is add one to this one because I want to offset it to the left. So we don't want like a empty half row at the end, right? Okay, first thing first, I'm going to create 2 loops, right? That goes for every row, every column, or every column, every row. Doesn't really matter. So let row equal, or let column, let's go with the column first, equal 0. Column is less than the columns. Call plus plus, there we go. And for let y, our row equal to 0, row is less than rows, row plus plus. Okay, there we go. Oh, shoot. Okay. Give me 1 second. Just take a look. Hot, really hot. Anyway, okay, great. So now let's just draw, like we said, we wanted to just start with the square. So let's start really simple. We don't want to make it complicated for ourselves. And I want, yeah, sure, that's fine. Okay, so let's do a rectangle that goes from row times the scale to, the call times the scale. I'll just copy this here, and here it'll be the row. Okay, great. And oh God, okay, and then config.scale by config.scale. Right? There we go. Okay, so we've got our grid. That's awesome. Can I only pass 3 variables in here? Oh yeah, I can make it behave like the square function, right? Because square only takes in 3 arguments, but it seems like rect also let us have the default value of the last argument to be the same as the third one. So that's totally cool. I'll still use rect just because we never know. Okay, great. Okay, now we need to shift to the left half of the scale, every even row, let's say. So we'll say if the row is divisible by 2 without any rest, that means it's even, right? So in here, we'll do, and then we'll do else here. There we go. We'll cut this. We could make this a lot better by just setting X or setting X basically, but I don't personally care. Okay, there we go, there we go. And then here we'll do columns, all of this minus scale divided by 2, right? So here, minus scale divided by 2. There you go. That should make it offset. Awesome. We're almost done. No, I'm just kidding. But we have a start. We have a start. So now the hexagons, right? I'm thinking. Let me see here. Let me zoom in. Can I zoom? No. Okay, I'll just get print and does that work? Joel? I don't know. Never mind. Never mind. Never mind. Let me just save as image. Sure. Why not? Let me open it. Okay, there we go. Now I can zoom in. So let me zoom in, right? So let me think. Is this right, what I'm saying? I don't think it is. Well, if we flipped it, would it be right? So let's take this hexagon, let's say. let's say we flip it once. Rotate, there we go. So let's take this hexagon, for example, right? So this one is half, so this row on top is half to the left, right? And it's a, I'd like to say a fourth, maybe? Sure, maybe a fourth up top as well. Okay, let's start doing stuff and see if it works, right? See, just throw rocks at it and see if it sticks. Because I think I'm a bit wrong in the explanation, because we'll need to also modify the height as well of them based on their columns, not only the row. So the row does offset, and I believe I'll need, like I said, I'll need to offset as well the height. No, well, based on the row, I should also offset the height, or the height shouldn't matter, right? They should maybe be closer together though. We'll see. We'll just do the hexagon, see if something's wrong. All right, so let's do the hexagon function, right? So function hexagon, awesome. We said x, y, and then some type of scale, and then some offset over here, which I won't put 0 in here. We'll always pass it anyway. Okay, great. So we need const 1, or we can make this like a constant, a global constant. It doesn't matter. It doesn't need to be recalculated every time. And we'll calculate it in setup, just because otherwise we won't have access to 2pi. I mean, we could have access to pi, so it's fine. We'll just do 1 equals mat.pi, and I'm using mat.pi, not just pi, the constant, because the constant is not available before setup. Times 2 divided by, so 2pi divided by 6, right? Because we have 6 sides. Okay, awesome. So 1. I don't think that's a great name for a variable, but whatever. I'm fine with it. If you're not fine with it, change the name, put it at something else. So I equals 0, I is less than 6, I plus plus, great. And now const a, or angle, equals I times 1. And here we'll do begin shape and end shape. Great. And now over here, what do we need? So I need x and y, const x. So I'll call these col and row. Col and row. Sure. X is going to be equal to the cos of the angle times, and let's do the scale, the full scale. I know I said I would do half scale because of, let's do the full scale because I'm just thinking right now, and it might be wrong to do half scale, definitely wrong to do half scale. Let's see. So let's do scale, and we'll need to add on to this the col times the scale. Yeah. And let me move this to over here somewhere. I don't need to calculate it. Well, let's do it stupidly. I mean, not stupidly, but the basic way, just calculating it every time in draw. This technically I would put not in draw, in the for loop. Technically this I would put somewhere else, elsewhere, maybe a constant even. Like it doesn't need to be calculated every time, but it's fine. We're just prototyping stuff right now, so totally fine. You can do it as well. It's fine. Or not, whatever. You do you. So now the row times, and this is to place it properly in the full thing. Okay, row times scale, and then let's do a vertex at x comma y. Okay, great. And let's do fill, and let's fill with a random color from our color palette, which we will find from over here, colors, if it wants to load sometime soon. There you go. So let's God. Let's explore palette. I would recommend this site always, colors20.co. Let's find a palette. This, maybe not blue. I'm tired of seeing blue. This pink one is great, but there's not enough of it. Maybe this one. I don't know. I'm difficult. I'm really picky. Sure. This looks good. The orange one, yeah, that's fine. So we'll do export palette, and we'll do code, I guess. Code Tailwind. CSV. No. Oh, with hashtag, exactly what I need. There you go. Let me copy this. Let me, no, not download. I don't need this. Okay. Great. Let's go back here. Let's do like a constant for the color. Const colors equals an array of colors. You wouldn't have thought, right? I just need to put the curly brace around them. There's probably an export value with the quotes or some other thing that would work, but I'm fine. There's not too much of them. There's maybe like 8 or 10. I don't know. Maybe 10 colors. That's fine. There we go. Almost there. Almost there. After that, we're going to be done with the colors, unless we want to add another one, another color palette, not just this one. But for the sake of this, I think this color palette should be more than fine. Okay. Okay, we've got there. So let's get this, right? So fill, and then I said I would pass the color in here. It doesn't really matter. Random colors. Okay, great. Let me call hexagon now over in here, right? Yeah, sure. So hexagon, passing it x, y, or column and row. So column and row, sure. Column, row, and then scale, config.scale, and then the offset. In this case, the offset is going to be it's going to be minus config.scale, right? I think. Okay. And let me comment this out. Let me copy this. I think there's something wrong with the code, but we'll see. I don't believe. There we go. Let me comment this out as well. Okay, there is definitely something wrong with the code. We'll see. So what is the issue now? Why is it doing stripes, right? X, Y, sin of the angle times the scale. Oh, plus, important. There you go. Okay, so we've got our hexagon, and let's do no stroke as well. No stroke, there you go. Okay. So it's a result. It's definitely not what we wanted. So scale too much here, right? Let's do divide by 2, just to see. Okay. It's not offsetted just because I would need to technically add the offset to the x, right? So plus offset, right? There you go. Now they're all offsetted. And I need to rotate them. We can see it right here, right? I need to rotate one of them. So I could technically pass in here something like odd equals, oh, it doesn't need, yeah, sure, odd. And then we can pass it here, odd to true, and here to false, right? And then we could say technically if, we could say in here, offset is fine, but offset is going to be calculated right here, for example, const offset equals if odd, then minus scale divided by 2, otherwise 0. And then also what I want to do here now, why is it all to the left a little bit? Not sure. Maybe I need more rows. Anyway, it doesn't matter. More columns, 1 more or 2 more. I don't know. Something's off screen. Anyway, it doesn't matter. Let's do this. What? Strange. Strange. Why is it not going to the right? I'm concerned. Oh, it's not the rows. I want to add one. It's the columns. Yeah, that makes sense. So +1 here should do the trick, right? There we go. Okay, so that's fine. That was the issue, actually. Okay. Okay, great. So now here, what I would like to do as well is if... No, we'll do push and pop over here. And we will not do these. We will move these outside of this. We will translate to this. Oh, not translate. I don't know what I wrote. It doesn't matter. Translate to these two values, right? There you go. Okay, let me add this in here. Okay, should still give us the same result. That's good. And we want to rotate by, I guess, 45 degree, right? Let me think. The triangle 180, it's 66, maybe by 30 degree, I'm thinking. I could be wrong. Let's see. Anyway, we'll do quarter pi for 45 degree and see if that's enough. I don't believe that will be enough because, oh, maybe. We'll see. We'll see. Anyway, so we'll say in here, if we'll basically repeat this. So if odd, then we want to rotate by quarter pi. What is the issue now? Ah, I didn't wrote it properly. There we go. Okay. So that is, I think, too little. No, too much. Let me map. Let me mute me again. There we go. So let map 30 that goes between 0 and 360. This is where you could say that using maybe degrees would be more useful. I don't mind using radians. It's totally fine. So between 0 and 2 pi, let's see. I think 30 degrees is right. Though, okay, so what's the issue now? We see here, right? It's not exactly, if we take a look at the image we had earlier. Where is it? It's gone now. Let me open it again. There we go. So you see here, right? This portion over here. This, I think, this top hexagon is fine for us, right? If we compare the two. Let me make the scale a lot bigger. Scale 100 maybe. Okay, that's fine. Okay, so I think you see this one is totally fine, right? It's the same as this one, for example, this one over here. But so yeah, let's take a look at this one, right? It's the same as this one or this one. So all of them needs to be oriented at the same angle, pretty much. Oh, okay, and easy. We just need to all turn them by 30 degree, right? That should just be it. So let me remove the condition here. There we go. Okay, great. We're pretty much done, I think. So the only difference here, instead of divide by 2, I might want to do something like scale divide by 3 times 2. Okay, too much. Divided by 5 times 3. Okay, we're getting closer to what we want. It's good. Divided by 7 times 4. Though my question now is, why is there more space around the y-axis? Where is there more spacing around rows than around each column? That's a good question, right? That's a good question. Maybe it's due on how the sin works. Yeah, maybe. It doesn't go as high as I thought. Maybe, right? I don't know. It's right now we're just messing around. It could be what you're looking for. It could not be as well, right? If I were to do divide by 2, yeah, there's twice more space around the x. Give me a second. All right, so yeah, we said there's about, maybe not twice the space, but let me do 5 again, right? Sorry, 4. Okay. There's definitely more space around them. Why is that? Let me just do by scale. It's way too big, I know. So let me do, okay, let me put this back to 5 or 4, sorry. And let me move the, y by row times minus row times scale divided by 4 divided by 3 divided by 2. Why? Oh, no. Divided by 5, right? 6, 7. Well, we're just trying right now. There's definitely a better way to do this. Let me see if I change the scale now, if it still works, right? Let me do 50 again. Okay, it still works. Phew, we're good. Though whenever I'll change this value over here, this fraction over here, it'll change. I will need to change this. So this is really not the way to do it, but who cares, right? I definitely don't, and I'll cheat a little bit. I'll definitely. I mean, I've been cheating, so I'm just going to continue cheating right now. I'm just cheating right now. But anyway, okay. Now I want to make this a little bit bigger of a gap, right? So maybe times divide by 7 times 3. Oh, maybe I don't. Okay, times 4, and we'll do 9 times 5. Okay. Maybe I don't need to change this value here from the scale. Okay, well, that's good. I thought I would. 11. Whoa. Okay, 11 times 5 times 6. 13 times 6 times 7. Okay, I think that's good spacing between each cells, each tiles. Okay, so we're at 30 minutes right now. That's totally fine. I think we're pretty much done. We're not going to add like noise for the colors. We'll just leave them random. You can try adding some noise to it so that maybe it's based on the height map, right? It shouldn't be long to add. You just do in here, you pass the color, and the color will be based on over here. You can just set X offset, Y offset, get the noise value for that offset, pass it here, right? Or pass, and then map that, which goes between 0 and 1 to the range of colors that you have, and then pass that color to here for the fill value, right? And then over here, I'm going to change the background for random in our colors, right? There we go. I think we're done with the sketch. Hopefully you think it looks good. I mean, it does look kind of interesting. I think it's less cool than what he did with his, right? He did multiple, right? If you were to change the value over here by 1 value, let's say, it's a different one. So that's cool. So he has like a random, this is like the random seed, for example, which is pretty cool, I have to say. Or this is changing the parameters themselves. I have no clue how he's doing it. but it is looking kind of great. I'll have to say every one of them looks cool, right? Oh, this one's great. So you see this, we can kind of see a height map, right? In here, kind of. Maybe it's not noise, maybe it's something else, right? Because there's also kind of random values in here that are popping out. But in any case, hopefully you liked us doing the sketch. I'll link down below as well his this Reddit post and also his website with this specific random seed value. So for you to try out, hopefully you go and give him props for it. But this was our version of it. I'll reduce the scale down to 20 maybe, right? To 10 even, not, or 10 I said. Okay, there we go. So this is, so you can see we've cheated. We can really see it now. So maybe like ×2. I'm really cheating right now. There's a way to calculate it. I just don't have the time. And there we go. And you can maybe have like here a variable for the spacing, right? Const spacing equals, and then right now I believe we're at 13 times times 6. I don't know. I don't remember. So you can put spacing in here. We're at 13 times 7, so we'll just change that for this. Times 13 times 7. No, give me 1 sec. We need to divide by the scale first, right? So we'll just do that here. There you go, right? Config .scale. There you go. So you could play with the spacing over here, right? If I wanted a little bit more spacing around them, and let's say a bigger scale, maybe 30, right? Sorry. So that's pretty much a sketch. Hopefully you liked it. Let me know down in the description down below if you think it's cool, if you want to see something else, whatever it is. Let me know. I'll try to take a look at it and see if we can do that for the next video. Thanks for watching. Leave a like if you liked the video as well. And make sure to check the description for the code itself and the link to the original post for this sketch. Thanks for watching. See you in the next video. Bye-bye.